In this problem, we're given a function f of t in the form f of t equals ae to the kt, where k would be the continuous rate as a decimal, and we're asked what that continuous rate is and what the annual percentage rate would be. This is a follow-up question, which is just a similar problem that I like to do at the end of the video where you have a negative rate as opposed to a positive rate. So we're given f of t in the form ae to the kt, where my initial value, sometimes called the start value, a is 356. And I'm given that k is 0.19, and k is the continuous rate as a decimal. And assuming t is in years, our k value of 0.19 would be the continuous annual rate, meaning the rate over a 1 year period. So if you converted k equals 0.19 from a decimal to a percentage by moving the decimal over twice, k would be 19%, and then to make it a rate, you would have to write per year, or you could just say it's the annual, the continuous annual rate, and the word annual would imply per year. So the continuous annual rate is pretty easy. You look at your k value, you make no changes except for move the decimal over twice. If it's positive, which this is, would be 19, you'd have 19% per year as your continuous rate. If it were negative, then it would simply just be that your continuous annual rate would be negative 19%. The more difficult part of the problem is figuring out what the annual percentage rate is without the word continuous, meaning what percent does this actually grow each year. So if it grows 19% at a continuous rate, that means it'll grow more than 19% per year. The question is, how much more? So to find that out, I would have to convert my equation from the form f of t equals ae to the kt to the form f of t equals ab to the t, more commonly known as y equals ab to the x, by the way. It's just we're using t rather than x for our input variable and f of t rather than y for our output variable. So comparing the two equations, notice that we have not relabeled a. The start value is still a. Our output variable is the same. In fact, everything lines up. F of t lines up, the equal signs line up, the start values are still the same, and our input variables are still t. The only difference between the formula that allows you to easily ascertain the continuous rate and the formula that makes finding the annual percentage rate easy to ascertain is that where you see e to the k here, it is b over here. So setting those equal to each other, you see that b is equal to e to the k. So for my k value, for k equals 0.19, given in the problem, I would have in my formula, I would have the same a value, 356, but my b would be equal to e to the k, and again, k is 0.19. When I find the percent rate, I want 3 decimal place accuracy, and I'm going to go to my calculator, but mind you that when you convert from b to the percentage rate, you lose a couple decimal place accuracy when you move the decimal place over twice. So when I type this in as second ln, gives me the e, the caret, and left parenthesis, 0.19. Close the left parenthesis with the right parenthesis, press enter. I'm going to round this to 5 decimal places, and you'll see at the end that we lose a couple when we do the actual final answer. So I get to 5 decimal places because this digit is a 9. I will round this 4 up to a 5. So I get 1.20925. So approximately 1.20925. So if you let me, I'm going to take the original equation of f of t equals 356 e to the 0.19 t, and then write down what I converted it to, which would be f of t equals, and remember that we left the output variable the same, and we left a the same. So if this a is 356, the a in my converted formula will be 356. And I'm still going to be using the input variable t. It's just where there was an e to the k before, i.e. e to the 0.19, we are instead going to write that as a single b value of 1.20925. So having said that, this is in the more familiar form now of y equals ab to the x, where my growth factor is here. And if you remember how to convert from a growth factor to the percent rate, you can think of it as you subtract 1 or ignore the 1, then you multiply by 100, or you could think of that as move the decimal over twice. So if you ignored the 1 and moved the decimal over twice, you would get that your percentage rate is 20.0 0.925%. And notice that even though I rounded to 5 digits, I am now only left with 3. So if you want 3 decimal place accuracy here, you have to round your B value to 5 decimal place accuracy. So my answer for the annual percentage rate would be 20.925%. Since you're using the word annual here, you would not have to write per year, but notice that if it just said what is the percentage rate, a rate does imply change over time, so you'd have to write per year. So in summary then, a continuous annual rate of 19%, notice I said continuous, is the same as an annual rate of 20.925%. Notice I did not say the word continuous here. So I like this conversion because it takes something that you may not be familiar with, such as continuous growth. What does continuous growth of 19% mean? It means that your start value of 356, whatever that quantity represents, if you wait 1 year, you're going to have more of it. How much more? You will have 20.925% more at the end of the year than when you started. So remember, I wanted to do another problem where this time your continuous rate is negative as opposed to positive. So the first question, what is the continuous rate? Assuming t is in years, our k value of negative 0.04 would give us the continuous annual rate if we only moved the decimal over twice and converted this to a percentage. Our k value of negative 0.04 would be our continuous rate as a decimal, and if you wanted to represent it as a percentage, you need only move the decimal over twice. So having a continuous rate of negative 0.04 means that it's going down 4% per year, and that would be the continuous annual rate. The harder of the two questions would be what is the annual percent rate, meaning what does it mean for something to go down at a continuous rate of 4% per year? So I'd like to convert that into what we normally would think of as percent change per year without the word continuous, and to do that I would have to convert our equation from the form that was given to us, which is f of t equals ae to the kt, where our start value was 356, that's a, and our continuous rate as a decimal k was negative 0.04, and I need to convert that to f of t equals ab to the t form, more commonly known as y equals ab to the x, but again we're using t rather than x for our input variable, and f of t as opposed to y for our output variable. Now once again, to get it in this form, I only have to notice that my b would be the same as e to the negative 0.04. So when I do my converting, a in this form is the same as the a in this form, meaning my start value is still going to be 356. I'm still going to use the output variable t. The question is, what happens when you take e to the negative 0.04 on your calculator, when you convert that from the number 2.718, roughly, e, and raise to that number, you get a single number for your b value. So to do that, I'm going to press second ln. That gives me an e, a caret, and a left parenthesis. I am to type in negative 0.04. Close the left parenthesis with a right, press enter to get a decimal approximation. I'm going to round to 5 decimals, 1, 2, 3, 4, 5. And since this is a digit higher than or equal to 5, in fact it's a 9, I will round this 8 up to a 9. So 0.96079 to 5 decimal places. So where I have e to the negative 0.04, I'm replacing that with a single number, we called that b, of 0.96079. And then we're using the same input variable t here. Now this is my b value. So now you need to do whatever your technique is for converting from a b value to percent change per year. And my method is to think of it as at time 0 you're at 356. If I was to plug in t equals 1, we wouldn't get 356, we'd get roughly 96% of 356, meaning we're keeping 96% of the value, but that means we're losing about 4%, right? If you're keeping 96%, that means you're discounting 4%, which is about the same as what we started with. So it's approximately negative 4%, but to show you the difference between a continuous rate and a regular rate, we need to use more than just 2 decimal places here. So going back to our calculator, if I took 100, I could, instead of subtracting off what we're keeping of 96%, I could use more decimal places and say we are keeping 96.079, and if you're keeping 96.079%, then that means you're losing 3.921. So if you wanted 3 decimal place accuracy, it's nice to help understand it by just saying it's going down about 4% a year. But the reason I don't like that answer is it implies that the continuous rate is the same as the annual rate, which simply cannot be the case. Whenever you compound infinitely many times, you cannot get the same continuous rate as a regular rate. So to more decimal places, going down 4% at a continuous rate is approximately the same thing as losing about 3.921%.